seventh grade tasks. And these are more conceptual maybe than what you might already have in your materials, or you might look up when you look for some, resources to complement these standards. This idea then, this task is directly connected to those first conceptual standards, where Mr. Briggs is polling his math class, and 2/3 of the students say that math is their favorite subject. Well, it's, it kind of bears thinking about then, if I'm polling a math class, is it necessarily going to be that that's a valid conclusion I can draw about the entire school? And so this is a great conceptual task from the sense that students have to provide a viable argument that whether or not they think that the newspaper article can draw, editor can draw the logical conclusion that everybody, that math is the most popular subject in the school. So there's a lot of different ways you could argue against this. So even the correct answer has more than one possibility here. So, and I love the part about suggesting a way to gather better data. There's, a whole lot of analysis then that students can put into that in terms of thinking about, well, if we're gonna draw this conclusion, do we have to sample the entire school? Do we have to put everybody's name in a hat and draw out 30 people to talk to? Those kind of things. So this is a nice kind of summative task for conceptual understanding. Then this next task is actually longer than one slide. There we go. So it's a task that gets a little more operational with analyzing the data distribution. So this is a dot plot from the University of Maryland, from their women's field hockey team and their women's basketball team, which field hockey is always women's, but in the South we don't know that because people down here don't play field hockey. So the interesting part is that there is a table of values that you could just give students the table and have them create their dot plot, or maybe you can just the dot plot and see if they can talk about what those values mean. So you could tailor this task depending upon what kind of data distribution kind of mechanics your students might need. So this is just the first part of the task. And then the next slide has kind of what students would be doing with the task. So I'm not going to read this to you. I'm just going to highlight a couple pieces. So you see there in part A, this is about kind of that visual inspection of the summary statistics. And remember, you're comparing two different populations, so you're absolutely meeting that 7th grade standard. So 6th grade standard, we don't do as much with two populations. 7th grade gets more about the comparison piece. But then you see in part B, they have to do the mean absolute deviation that they learned in 6th grade. So next year, 7th grade teachers, you may have to go back and teach mean, and 8th grade teachers for that matter, you may have to go back and teach mean absolute deviation in order to have students make those summary analyses about two different populations. Part C just asks you kind of, can you read the graph and make some comparisons between the two populations with some specific data points. And then part D gets into this idea, if you had to add some new data to your population, a new person to your population, a new member of the population, then if they have these characteristics, where might they fall? Which population might they best fall in? And then they talk about this, how can you randomize this to make this a sample? And then if you randomize it and pick a player, what characteristics might they have? Do you think that, that usually the college basketball players are taller than college field hockey players? So you have to explain your decisions, not just because you think basketball people are taller, but because you're going to use the answers to your previous questions or some additional analysis. So this is a huge task but you can see it kind of brings all the 7th grade pieces and parts together. So if you were to use many of the 7th, not all the 7th grade, but many of the 7th, not as much probability rather. But if you were to use this, as a way to help, as a vision of where you're going with your statistical unit in 7th grade, it can help you see, oh, wow, I've got to do some of these pieces and parts so that students can then be successful in this kind of summative task. Yeah, I'm not sure why, but every time I change a slide, it changes top screen sharing, so I'm not sure what's going on. Okay, so 7th grade then, you can see that we're really about this idea of comparing two populations. So I've got to know about those 6th grade standards enough so that then I can compare two populations in the introduction of more formal probability. In 8th grade then, we really start to get kind of sophisticated in our understanding of data. And so we're really looking at patterns of association between two quantities. Now, this is, a major concept because a lot of times people get confused about correlation and causation and association and causation. And so two things may be associated, but they might not be causing each other. And so that's the part where I think we can probably do a major service to the general public if we do a really good job of teaching this in 8th grade, is that you're going to look at what's called bivariate measurement data. What is that? Well, it's actually not as rocket science-y as it may sound. It's just data that has two components that you can graph on a coordinate plane rather than on a dot plot. And so it's not how many 65-inch people I have, but it's the relationship between two things. And you'll see a couple of examples here in just a moment. And then, so then this idea about scatter plots, and that's really what the bivariate data is. It's data that can be shown on a scatter plot because a scatter plot has two components. And so we're looking for kind of, visually how things cluster. Does it look like it's linear? Does it have a positive or a negative association? So those kind of general inspection kind of statistics that you want to look for. And you'll see some examples here in a moment. Then the second piece gets into this idea of modeling. So we have this, relationship that I can put on a scatter plot, like maybe it's my arm length versus my height. And then I want to see if I can model that relationship with a straight line. Well, it's not going to be a perfect model, but it's going to be one that kind of fits. And so, there'll be an informal fitting for 8th grade that involves this idea that you want to get as close as possible to the data point. And so they'll have to kind of make that judgment about the closeness. Now, the point here, another important point to make is that this is not going to be data that's kind of cloudy. It's going to be data that's pretty nicely clustered so that then you can approximate it and provide a defensible argument of a positive or a negative correlation. So, it's not the formal kind of line fitting algebra that kids will do in high school. This is more about just understanding that we can model. And then number 3 then is, okay, if I give you a model, then how can you use that model to solve problems and interpret what the slope and intercept mean? So this has a direct horizontal connection to what the kids are doing with their algebra studies in 8th grade, but it also has that, coherence in terms of connecting to a real world situation. And so number 2 and number 3 are kind of like backwards from each other. So number 2 is, okay, I'm going to have a scatter plot, and can I informally fit a line and talk about if it's a good model or not? Number 3 is, okay, now here's the line. now, how can you solve problems with this line? So, it's kind of like you give one in the first one, you give the other one in the second one. So, and then extending that understanding then to get a little more formal with the analysis, to do a frequency table, and we'll look at an example of that here in a minute. So again, as with some of the things I've mentioned in the past, like the mean absolute deviation, it may be that for your 8th grade teachers that we have to do a little studying up on what these standards mean and what it means to have a table, what it means to have, categorical variables, that kind of thing. So, yeah, we'll talk about that more as we go along.